Hello and welcome back to the CCENT journey with me, Ryan. In this next section, we're going to continue with the routing section of the CCENT or ICND1, and we're going to dive deeper into understanding static and dynamic routing from a very high level point of view. In the last video, we talked about why routing was needed, and we jumped onto packet tracer, and we went through the verification steps to understand what was missing and how we would get traffic off the local network. So let's go over static and dynamic routing. For those who don't know, you can contact me here on YouTube, on LinkedIn or Twitter. So let's start by having a high level discussion about static and dynamic routing. And here we're going to begin with static routing. So first of all, what do we want to know about it? It's used in smaller designs. So we've got 2 or 3 routers and they're not doing anything fancy. Then let's not overcomplicate things, let's add static routing. As network engineers, you realize that the more and more you design, the best approach is always the simplest approach. The downside to static routing is it does require hands-on to set up and hands-on to maintain, and it's not dynamic. So a good flaw to explain with static routing is, let's say we have a router connected to a switch, and on the back of that switch we also have another router. Now this is something we're going to go into a bit more depth, but I'll give you a high level view now. Let's have a think of what we know already between these 2 routers. We know that this link to this link, there are layer 1 and layer 2 checks, i.e. is something plugged in, is it Ethernet? If I disconnect this cable, we know this interface will remain up because the link to the switch is also up. Well, this here actually identifies one of the biggest flaws with static routing. Without adding any additional intelligence, if I was to add a static route to tell this router, if you want to access network X, which is off the back of this router, go towards this next hop. Providing the link towards the switch is actually up, it will try to route that traffic even though the link between the switch and the end destination is actually down. So because of that, we would need to add some sort of intelligence like IPSLA or track statements to actually ensure that this router is able to confirm connectivity end to end before using that static route. If we used something like dynamic routing in this scenario, then we would have some sort of keep alive mechanism between the 2 endpoints through the switch. This means that if the link were to go down here, then no keep alives will be sent from the router to this router, and as such the route can be removed and traffic will not be sent and in turn will not be black holed. This is something we'll go into in a bit more detail, but it's very important to understand how routing is affected on a per hop basis depending on which technology, i.e. static or dynamic routing, you use to achieve a particular goal. It's always preferred by default over any other dynamic routing. Now, route selection is something we've not talked about, and it will be in the upcoming videos, where the router itself goes through a selection process. Because a router, when it runs its process, it can run a bunch of dynamic processes and static routing. So for example, a router can run RIP, the Routing Information Protocol, which is a variant of dynamic routing. It can also run simultaneously OSPF, the Open Shortest Path First protocol, which again is a dynamic routing protocol, and it can also run static routing. If it has all of these processes learning all different routes, all of them are presented to the router, and the router makes a decision based on a set of rules, and those rules can be determined and changed by administrators. However, by default, it's always going to prefer a static route over a dynamic route. And when I say that, I say it with a clause, because like most things in networking, there's always an if and a but. And here, what we're saying is we always prefer static routing over dynamic routing if nothing is changed, so hence the by default, and if the route is the same length. So if I learn a /24 via RIP, the same /24 via OSPF, and the same /24 via static, Providing nothing else has been changed, I will prefer the static. The route selection process, as I said, we'll get into in more depth later because it can get complicated, but we will understand the very high level basics which is required for the ICND1 or the CCENT. Next is, because it's always preferred by default, we can use it to bypass around certain challenges or for quick traffic engineering. So for an example, let's say we have a couple of routers connected like so, and all of these routers are running RIP, the Routing Information Protocol, which again is a dynamic routing protocol. This means that each router is talking to one another in the RIP language and telling each other how to reach their subnets. So let's say we have subnet Y, subnet V, and subnet X. Every router knows how to reach every other subnet because of RIP. Well, let's say, for example, that this router has both Y and Z, and this particular path here is the best path that RIP has picked for any traffic from X to Y or Z. This means that the link to V and up, as in these two links, are not being utilized for any traffic between X, Y, and Z. However, let's say as an engineer, we're paying for these two links and we want, for example, any traffic to the Z network to route over this link. Well, what we can do is on this particular router, we can set a static route to push the traffic to V, and V in turn will push it to the path it has to Z. This will help us overcome some quick traffic engineering to change the particular path. However, when we make these sort of changes, we need to keep in mind a few things. First of all, we need to make sure that there is some sort of mechanism to track the route, because if the path were to go down, let's say here, we want to make sure that traffic can fall back to the original path via RIP. How is it actually set up? Very simple. We go into the config, the global config, and we type in the keywords IP route. We use the destination network and destination subnet mask, and then we point it to the next hop. So if we have two routers, and these two routers are connected through a network, let's say 192.168.0.0/30, here is .1, and here is .2, and behind this router we have, let's say, 10.0.0.0/8. Well, we can go onto this router and we can simply say IP route 10.0.0.255.0.0.0 with the next hop of 192.168.0.2. Now notice that we use the remote IP on the link. We do not use our own IP. So that's the first key bit. We have to use the remote IP. When we talk about static routing in more detail as we move on the course, we'll understand why that's important that we have to use the next hop, and it's important why we use an IP address and we don't specify the local interface. And just below you can see I've got another example here. So this is kind of the reverse of what we just done in a sense. This is saying if you want to get to the 192.168.0/24 network, go to the next hop of 10.10.10.1. So what about the verification side? We have a few commands here. We have show IP route. This was the command that we used in the previous video to look at the routing table, but we can put the keyword of static on the end, which says show me the routes that I've actually got which are static. So it kind of filters out the routing table for us. We can do the same command, show IP route, but we can filter it based on a prefix. So if we put this command in and we then said show IP route 192.168.1.1.1.2.1.5.100, anything in this /24, then it will tell us how the router has installed that route. Is it via static? Is it via a dynamic routing protocol? Is it directly connected? It will give us a bit more information around some attributes of the link, such as which is the AD, which is the metric, and anything else that may be applicable to that particular route type. We can then also do the show running config. Obviously, show run config will show us the entire config, but then we can use this thing called a pipe and pipe it to include only the keyword of IP route. Something which is worth mentioning is, in an ideal situation, we should really, as engineers, be avoiding the running configuration as a verification tool, because the running configuration shows us the configuration. It does not show us the output or the impact of that configuration. So an example of that, if we done the show running config include IP route, it will rightly so show us the IP route command that we typed into our router. However, what it won't show us is whether that command is taking effect and what impact that command actually has on us. So in order to do that, we would need to use the correct verification command in order to see the output of that command. Only because it's in your running config does not mean it's actually taken effect. There's a key distinction to be used there. A lot of engineers look at the running config, they see it's there as a part of the configuration, and they believe it's in place. Don't get confused between configuration and verification. Moving on to dynamic routing. So dynamic routing is used where static routing is not, in basically all other design cases, from small enterprises to large service providers. Most of the networks it'd be working on would be using dynamic routing, and then static routing will be used in different parts of the network, or, as we've seen just now, as a traffic engineering tool to achieve a certain goal. Before we continue with the presentation, let's have a quick high-level view of what is dynamic routing. Well, in the previous example, we had that triangulation between three routers. And we said that these three routers were, let's say, router A, router B, and router C. And off the back of them, they had different subnets. Let's say subnet Y, X, V, and W. Random characters. And the way it would work would be, as we enabled our routing protocols on these interfaces connecting between the actual routers themselves, let's say for example that's RIP. RIP will start sending out their packets advertising all the routes that each router is aware of. And eventually, once those packets are sent to each other, any router will have access and some sort of path towards any other network. So network V will have a path towards X, and then through some sort of calculation they will decide which is the best path. So for example, let's say V wants to speak to X. It knows that it is directly connected to X through router A, and it knows this is the best path rather than going up through to C across to A. However, if this path were to go down, after a set period of time, it will then know that it can reach X through an alternative path towards X via C, and if the path were to come back, then it can use the better path and it will dynamically flip back and forth, ensuring there is full reachability without any administrative overhead. So let's continue having a discussion around dynamic routing. Dynamic routing also has two subcategories, which is IGP and EGP. IGP is the interior gateway protocol and EGP is the exterior gateway protocol. Now for the CCNA, you're primarily focusing on IGPs. These are protocols such as RIP, OSPF, EIGRP, and within the CCENT or ICND1, only RIP is part of the actual syllabus. You need to be aware of OSPF and EIGRP in the sense of understanding route selection when they're included, but as far as the configuration and verification is concerned, RIP is the only one on the official ICND1 blueprint. And there's the other category called EGP, which only has one protocol, which is BGP, the Border Gateway Protocol. So let's have a discussion really briefly around the differences between an IGP and an EGP. An IGP, as I said, is an interior gateway protocol, and an EGP is an exterior gateway protocol. Now, interior and exterior gateway protocols are different. They behave completely differently, and they're used in different scenarios. Now, if we have a think about a network, let's say this network has a bunch of routers in it, and they're owned and managed by a single person. This is referred to as an autonomous system, a single administrative control for the entire network. Within the autonomous systems, we would normally run some sort of IGP protocol. So as previously mentioned, these IGP protocols are things like the RIP process, or the Routing Information Protocol, OSPF, Open Shortest Path First, EIGRP, the Enhanced Interior Gateway Protocol, and this is what's used inside the autonomous system. So they don't need to match and they don't need to communicate. So maybe this network down here is running RIP and OSPF, and this network up here is running RIP and EIGRP. Well, what we could do then is we would have to run some sort of protocol between the autonomous systems in order to connect them up. Because if you think about the internet is just a bunch of autonomous systems, a bunch of single administrative controls, different companies connecting together to form one giant network. And the EGP, which we said earlier, which is actually only one, BGP, will be used between the autonomous systems. Now, one thing to keep in mind is even though we say BGP is an EGP and RIP, OSPF and so forth are IGPs, there is nothing stopping us as administrators to then adopt BGP within our network, or some oddly designed, you might actually have some sort of IGP between different autonomous systems. However, as far as the CCENT is concerned, as far as ICND1 is concerned, there are two subcategories, IGP and EGP. IGP is used within an autonomous system, and EGPs are used between autonomous systems. And an autonomous system is a single administrative control, whether that's a single company that has a huge network, or whether that's a single person that controls multiple networks. Both dynamic and static can be used together, and even multiple dynamic on a single device. We said this before, that you can have RIP, OSPF, EIGRP and static routing all on the same router. Very rare case that you would have that, but there is an option. It's something to be aware of. If you have some sort of what we call redistribution points, let's say you have a network that's running RIP on these two links between the routers, and then you'll have a different part of the network which is running EIGRP over here, then you need the router in the middle to actually run both EIGRP and RIP as it moves routes to and from RIP and EIGRP. And this is referred to as redistribution, which is something outside the scope of the CCENT and potentially the CCNA. But it's something that you need to be aware of, that if there are multiple routing processes on the router, what are we actually going to prefer and why? Different dynamic routing protocols like EIGRP, OSPF, RIP offers different benefits, and those benefits depend on the actual design you're looking to achieve. That's something that doesn't go into the CCENT in detail, because like I said, we only need to be aware of these routing protocols. The one that we need to be fully comfortable with is RIP. We need to know how to configure it, how to verify it, and how it affects routing based on its behavior and how it interacts with other protocols and static routing. So what about the configuration of this? Well, here's a quick example. We first of all go into the global config. We type in router, and then here we use either OSPF, EIGRP, and so forth, but you can see we simply select the RIP process for now. It puts us into a sub-configuration mode where you specify network and then which network you wish to enable the process on. Now what this actually does, this network command, is go off and it looks at your connected interfaces and it finds the interface that has the 10.0.0.0 network on, let's say Fast Ethernet 00, and it starts the RIP process. So it actually starts sending RIP data or RIP packets out that interface towards a neighboring device. And obviously when we get into RIP in more detail, we will go through the configuration and the verification. Here I'm using RIP as an example of how you enable dynamic routing. Then how would you verify it? We can look at the routing table again, but this time instead of static, we can put in the routing protocol that we're interested in. We can look at the route that we're actually specifically interested in. So if we were to do show IP route, let's say 10, then it will tell us that we've learned a RIP route out that interface and the details about that RIP route, like for example the metric. Again, we can look at the running config to look at the configuration to confirm that we've typed it correctly. It won't tell us if it's been applied and whether it's functional, but it will tell us does it actually exist in the configuration. And then show IP protocols. This will tell us things such as what networks have we enabled the RIP process on, what are our timers for the protocol, and much more information. And some of the output will change depending on which dynamic routing we actually choose to use. Okay, so that's all we've got time for in this lesson. In the last video we talked about why routing was needed. We looked at the routing tables and noticed that routers only install their directly connected networks. And if we want to get off our directly connected networks to a remote network, then we need some sort of static routing to tell the local router how to get to the remote network, or we need some sort of dynamic routing for the two routers to be able to communicate to one another and able to advertise the routes that they are aware of. We said that dynamic routing comes in two flavors: IGP, the interior gateway protocols, which are things like RIP, OSPF, EIGRP, and then there is EGP, which is the exterior gateway protocols, which essentially there's only one, which is BGP. We had a discussion between the differences between EGP and IGP. We said that IGPs are used within autonomous systems, within a network, within a company, and EGPs or BGP is used between autonomous systems or between companies. We also then looked at the benefits of dynamic routing and why you would want to use it. We said that dynamic routing is dynamic in its right, meaning that it doesn't require the administrator to do much work. It will advertise the routes so everyone is aware of everything, and then we can, if we wanted to, do some traffic engineering over the top to control which paths are used and which paths are not used. In the next video, we'll go over path selection and we'll go into actually configuring static and dynamic routing. I hope this video has been informative. I'd like to thank you for viewing, and if it has been, please do like and subscribe.